Hello students, my name is Mr. Dhawale from Department of Chemistry, RBNB College, Sri Rampur. In today's topic, we learn one question regarding the size of a ring system. Okay, in that case, we have one question. If we take two example of comparison in its diagonal angle, if you take here cyclohexane ring and cyclopentane ring, suppose here we have one example, cyclohexane 1,2-diol and cyclopentane 1,2-diol. Suppose here we have two trans isomers and cis isomers. If we react cyclohexane 1,2-diol with lead tetraacetate and also cyclopentane 1,2-diol with lead tetraacetate, at that time we have two different rate of reactions, and in that case here, suppose we try to convert that simple structure into the chair conformation. These are the two chairs. Suppose here this is OH and this is another OH. This is a trans, and here in case of five-membered ring system we have this is five-membered ring, and here also two hydroxyl groups, and these are trans isomer. Okay, so in this case also this is trans, and if we have cis isomer, in cis, suppose this is the axial hydroxyl and this one is the equatorial hydroxyl group, and here suppose we have this is also a cis isomer. But when we take this such a type of reaction with lead tetraacetate, at that time we have seen the rate difference between these two is somewhat differentiate, and in case of cyclohexane 1,2-diol, cis is near about 22 times more reactive, or 22 times faster than its trans isomer, and here this is 3,000 times faster than its corresponding trans isomer. Okay, so friends, now we have to explain why the rate of cyclopentane 1,2-diol cis isomer has very fast 3,000 times. It is greater than that of when we compare that with the six-membered ring having 1,2-diol, and cis isomer in case of 1,2-diol cyclohexane gives only 22 times faster than that of its corresponding trans isomer. So why this difference is less and why this difference is large? And for getting the idea about this such a type of differentiation in rate of reaction, we can take some idea from the model. Suppose here we make one model of cyclohexane and for cyclopentane. Now first we try to make a model of 6-membered ring, and here you see this is 6-membered ring. Okay, this is 6-membered cyclohexane which is in chair form, and suppose we have cis isomer. Okay, like this. Suppose this red color bond represents the hydroxyl group and white color bond represent the position of hydrogen. Okay, now you see here this is cyclohexane chair form, and as we say, this red color two bonds can give the position of cis-1,2 diol. Means what? Here one hydroxyl group and here one hydroxyl group is present in cis isomer, and the dihedral angle between them is near about 60. Means what? Suppose we see here this hydrogen and this hydroxyl group. In between these two groups, the backside hydroxyl group is sandwiched. Okay, and its dihedral angle between this hydroxyl and this hydroxyl group is exactly 60 degree. So if the dihedral angle between this is high, at that time when that molecule reacts with lead tetraacetate, at that time it gives a slow reaction. Okay, so suppose we write its mechanism with lead tetraacetate. Here this cyclohexane with cis isomer, okay, plus lead tetraacetate, OAC, 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 and this is also another OAC. Okay, now you write its mechanism. Lone pair on this hydroxyl oxygen is able to attack on this lead, and then OAC, one molecule leaved out, and same situation is observed in another hydroxyl group, and another acetate group will leave out, and we have one intermediate, and that intermediate can show or can be represent the rate of reaction. Okay, this is one of the intermediate having 5-membered cyclic ring system, and in this case 5-membered cyclic ring system can form very easily if the dihedral angle between hydroxyl group is less. At that time this intermediate can form very easily and faster. But in this case here, when we take a 6-membered ring, cis isomer, this is cis isomer, and if we take another example about trans isomer, if we take trans isomer, at that time also the dihedral angle between both the hydroxyl group is same as shown in the cis isomer. Suppose we look at model, at that time you also see when suppose this is a cis isomer having both the hydroxyl groups are on the same side, but now here we replace these bonds and position of hydroxyl group. Now this hydrogen is at axial and here both the hydroxyl groups are at equatorial condition. One is beta and another one is alpha. At that time also, if we see here, both the hydroxyl groups are in its same diagonal angle, means this is near about 60 degree, so that there is no a huge change or large difference in its rate. Okay, so that the rate of reaction in between, or rate difference in the rate reaction of cis and trans isomer is very less, and it is near about 22 times faster only. But when we go for the next sized reaction, or 1,2-diol, if we take another example, or we take this example also, only we can change the size of 6-membered ring is converted into the 5-membered ring now, and we make changes in that example. Okay, and here we see this is 5-membered ring, and here also we have 5-membered ring. So we get a result. In this case also such type of intermediate we get, but in this case the rate is faster, near about 3000 times. Okay, in this case we have seen the diagonal angle between two hydroxyl groups in case of 5-membered ring system, that is very less, and it is nearly equal to 0. Okay, and here we try to make that example also. Suppose we can remove one hydrogen from the model, and we get here, this is your cis isomer, cis hydroxyl. Okay, and here suppose we see that is not exactly 60 degree, but which is not less than this is less than 20 degree, and here this is nearly eclipsed. Two hydroxyl groups are nearly eclipsed, and that's why there is formation of intermediate like 5-membered cyclic ring. Okay, and that reaction is so much faster as compared to it is shown in the 6-membered ring. When we try to say here about a trans 1,2-diol, okay, now we have this structure is trans 1,2-diol, and in that case the diagonal angle between these two hydroxyl groups are nearly equal to 180 and less than somewhat 180, but the large difference in between is diagonal angle, and so that there is a so much drastic condition for making the cyclic 5-membered ring. Why? Because the greater diagonal angle, and due to this large diagonal angle the rate of reaction with lead tetraacetate is very less, and so that the difference between this reaction cis and trans isomer is so much, and which is near about 3000 times faster than that of its corresponding 6-membered ring system. So you remember, student, about this, and such type of so many examples are always asked in examination. So in this case you only remember about the diagonal angle between cis and trans 1,2-diol. If the diagonal angle is less, at that time its reactivity is more as compared to its trans isomer, and if the diagonal angle is nearly eclipsed, at that time there is formation of intermediate like this cyclic ring, 5-membered cyclic ring, and this type of 5-membered cyclic rings are very easily formed due to the less diagonal angle, and that diagonal angle between this is very less, near about 0 degree. Okay, so regarding this, if you have another examples, suppose you can choose a 4-membered ring system and 5-membered ring system. At that time cis and trans isomer of 4-membered ring system is very much large difference in its rate of reaction with lead tetraacetate is shown as compared to 5-membered ring system. Okay, even in 4-member ring system, that reaction is not carry out in case of trans isomer. Why? Because its diagonal angle is very large and there is no formation of 5-member cyclic intermediate. So that such type of examples are also asked in examination. So you remember the basic concept regarding such type of reaction when the reactant is near about 1,2-diol in ring system, and when it reacts with such type of lead tetraacetate. Okay, and also you take so many examples like this, but as a representative we take this one. Okay, and in the next lecture we see about another points in cyclic ring system and stereochemistry of other compounds. Okay, thank you.